Okay. Right, well, thanks everybody. Welcome to this rendezvous on Python with JavaScript sprinkles. And basically, it's going to be quite an interactive session. We've got, to start with, Wesley's got a presentation to take us through, just to guide us through some of the main questions, why we're trying to do this sort of approach and why you might want to do this sort of approach. And then a few of the solutions that we've picked out so far and been playing with around a couple of the different libraries that we're going to step through. And in between that, we're going to hop back and forward a little bit between Jupyter and Reveal.js and Curve Note in terms of different places where these plots are embedded. And hopefully the idea is it'll give everybody a flavor of some of the things we found out that work and some of the things that we still haven't figured out yet, and some of the patterns that maybe don't fit this quite as well. And what it would be good to do around that is, I don't know, just to hear from everybody what they've been trying to do with interactive plotting and the types of things they'd like to try and do. And we can see if we can figure out if there are any other methods too. So maybe if, just before we get started, there's a little sort of reactions thing in Zoom, and you can raise your hands or feel free to unmute. But who's all used bokeh to date? Yeah.
Very badly, I'll add.
Okay, so that's between Plotly, Dash. There's one. I know Wesley has as well. So there's one or two. And then I guess the Matplotlib, everybody. Yeah, and the static. Okay, cool. And a panel. Just one I've just started. Panel is an interesting one too. Okay, cool. So sort of know there's a little bit. There's okay. Matplotlib and a bit of bokeh, and then Plotly is down at the bottom. Cool. Well, we'll let Wesley share his screen. And
thanks.
start
I
taking us through.
Literally just get everything working. So that's good. Probably just share my screen is going to be best to make sure nothing wrong happens. Can everyone see this?
Yeah.
Yep.
Stick it up there. Right. So this is sort of like the. Oh, doesn't want to go away. Anyway. So this is the get rid of that as well. So this is more of the theoretical side of things, like why we wanted to try and get this done. So yeah, like Steve says, we both put this presentation together and hopefully it's going to be of interest. So before we start, this is more on my behalf, but Steve could probably pitch in here as well, is I'm by no means a pro at this, and it's just stuff that we've recently been experimenting with and it seems to work. So we wanted to share it with the community to sort of like stimulate, I guess, other people using it and seeing how they could do cool stuff with it as well. So how this part of it is going to work is we're going to look at like why interactivity is good. Why do you need to add extra stuff to your code that's already complicated and annoying to write to get to do this little bit extra? How all that works together, and then we're going to run through some the examples. This is like what Steve was talking about earlier, and then just quickly hit on those pain points that we've got so far. So this presentation is in a GitHub I can share with you later as well, so you can always get hold of this later if you want to see any of it. And hopefully I'm going to fill out this what didn't work with a few more examples as we're going through and seeing stuff that breaks. So interactivity. I can sort of imagine like when people started graphing is we'd be sat here in a terminal somewhere. So this is like back like before I was born probably, and they're doing these graphs online over an SSH connection, and you're getting these very basic graphs. So it took a long, like there's only a limited certain amount of visualization you can do, obviously, because well, you can only plot things in a certain manner. It's going to be hard to analyze because everything's static. It's like everything, you can't go and interrogate points. And like if you want to make a change, I mean, here you've only got a few parameters you can change, but I mean, it's still quite like you've got to re-execute everything each time. After that is we kind of moved on to graphical plotting. So people in my lab are still currently using like X11 servers and passing graphical windows through. So this has kind of got the same drawbacks as we had to begin with. Is there a way? Same drawbacks as sort of like plotting in your terminal, in the sense that you've still got to re-execute all your code each time. It kind of gets annoying and it's quite cumbersome to change. X11 is notoriously slow as well, which is a real pain. And every time you want to change something, you just got to re-execute everything. So why interactivity is good is for data exploration is even though you've got to add a bit of extra code to begin with, is it gives you less code as a whole. It's like if I want to change a color plot, I can just add that in as an option to begin with, and I can start doing stuff dynamically. So for example, here's just a power curve. And rather than like having to replot this a million times, is I can just add a slide to that power curve and then start exploring what my graph would look like. And similarly as well, is because it's interactive, is we can then go and zoom and see different things. Whereas if I was doing this in a more traditional manner, is you got to replot that every single time and then sort of like try and compare how these things are working. Whereas doing it in this manner is you don't. So that's why interactivity is really, I feel, something scientifically that is very important to us today in the way we work. So this is great. It's like we've seen we can do interactive graphs, but like how do we collaborate around it? So like I'll be sat at my computer and go, okay, I've got this graph that does something, and then I might want to talk to Steve and go, okay, Steve, what do you think about this? And short of taking a screenshot and sharing that is it gets a bit complicated. So the general sharing methods and general interactivity nowadays goes through some sort of form of Jupyter. So I mean, I say Jupyter is a large. There's also other projects I know that exist that are parallel to this. But anyway, so if we just go along the Jupyter method sort of idea, is I can go, okay, here you go, Steve, here's my notebook. But then if Steve wants to see what's in there, is he needs to have a notebook server to be able to read that notebook. He may need to have to rerun the notebook because all of the interactivity and all the stuff's kind of broken in it, which means that he needs to make sure he has the same data, he has the same libraries installed, because I mean the libraries, even different versions, can sometimes cause problems. There is something though I believe that should save state. Maybe Steve could touch on this. If you do the Jupyter Lab settings, you can save the widget state automatically. I don't know if you got something to say on that, Steve, if that would help.
It does, but it only saves partly. There's two things that can make a notebook massive, and it can make your notebook big. It's not currently working well in Jupyter Lab, but it does in Jupyter Classic better. But the thing
I
is,
guess it saves everything as well. Like it will save every single one of your plots, even if I don't want to show you every single one.
Yeah, there is that. But it also just saves the widget model and the widget view. So if it won't say, if you have a slider, for example, that is down picking a different image. So for example, there's an IPy widgets example where you can go through the MNIST machine learning data set for character recognition, and you move the slider and it loads up little versions of the image. You can save the whole state, but you'll only get the last image displayed, saved in that state. So when you come to, so it's broken, you get slider interactivity working in your HTML, but it doesn't load any of the images because it doesn't go that far. And that's the bit that's disappointing, because it seems like it should give you everything, because you know it's trying to embed the slider for you, but it doesn't. So that doesn't work really.
Some of the other ways with Jupyter as well, so rather than going, here, Steve, here's my .ipy notebook, is we can export Jupyter stuff. So it exports the whole notebook. It's just like the file save as export. And in general, it's like, I mean, for interactivity stuff, you probably do that with HTML, but there's the HTML export. But again, it's because there's no back end, is I think we're probably gonna be hitting these same problems here in general, is we get these Jupyter Lab save widgets, is basic interactivity at work. So like the bokeh plots may work, but as Steve was saying, like multiple states will not work, and the same for complex interactivity. So like if I have a little slider that's meant to do something on my plot, like I did in my previous slide where I just changed the power law, that's definitely not going to work if I export it just without doing anything extra.
I think panel would work as well.
The panel embeds, though, you have to export them still. So we are looking, we got some of those examples later. If you don't do the embed, is that you get the static file out, but all of the interactivity between the others doesn't seem to play nice. So it gets all the layout correct, but like if so with panel is like you get the little time sliders for your coordinates and things like that, is those will move, but they won't update the data unless you do the panel.embed.
Yeah, I just remember I did with PyVista and panel, and then you had these 3D models that you could move around. And if you export it as HTML in the notebook, it would still be a 3D model you can move around as HTML.
Yes, that's what I'm calling the basic interactivity, I guess. So like if you just go back to if we go back to this slide here, so basic interactivity here is like 3D model, I can still move it around, I can still zoom. Yeah. But the custom interactivity is I change a slider. So we got some examples later where there's panel with extra sliders like this. It's all automatically generated by panel. Like it's really easy to code. But if you don't do the .embed function on the panel object, it will not render. Like the interactivity won't work. So like we're saying, so again, no complex interactivity. So this is what we're calling complex yet, like interactions. So why do we need to use Python? Like why add this extra little bits of JavaScript and make sure that how we're modifying the plot is happening in JavaScript and not in Python? So what this does is like, well, to begin, sorry, this isn't necessarily just the Python and JavaScript part. This is like in general, is doing a method like this rather than doing the export the whole notebook. Like if I go here, Steve, I want you to look at this, is rather than Steve having to look through my whole notebook and understand what I'm trying to show him, is here we're talking about more just a way to export certain graphs or like compact. I don't like saying the word that, like what panel does, like compact figures that are all one thing already. So that's one of the things that we were working on today. It's not like exporting the whole notebook and getting everything in the notebook to work straight away. It's just exporting the thing we want to talk about. And the beauty of standalone graphs is they can work anywhere. So here I'm using, like Steve said earlier, a framework called Reveal.js, which is for presentations. And what's really cool about that is because it's written all in HTML and JavaScript, is we can start embedding graphics in here. So like, as you saw earlier, I had an interactive graph. Here again, I've got another interactive graph, and we're going to see quite a few in here. So like I can hover over my data points. It's not working too well because this plot's broken a bit, but still, we still see that we can zoom. We can see our data values. And for like communication purposes, this is really interesting because rather than sat there and like talking your presentation as you go, okay, like what would happen if we just move this graph slightly, is now we can actually go and zoom in and see the data, why you're presenting, why you've got the stakeholder in front of you, and why you're talking to people. There's also a move with products like CurveNote towards interactive documents. So in this case here is we can create a CurveNote article, for example, that's the same as we got text, we got values, we got text, we got our headings and everything. But rather than having that static document, is we can now start creating. I probably should have made that icon a slightly bit bigger. If I can zoom out, is this going to make it? Oh, that's going the wrong way. Is we can actually start adding in graphs inside our documents that give us value. So again, here is like if I have a, this is an upside down topography, but I can change my values or my variables inside documents and then communicate that with people in an interactive manner without them having to see the code at all. And this is allowing people, like I can send this, or in this case here, I can send a link in the presentation. I can send you all the presentation afterwards. And it's just in a portable manner that everyone that has a web browser nowadays can just open up the file and read it. And finally, you can use static websites. So rather than having, like in general, it's like if you want to give panel to someone or bokeh to someone or plotly or dash or anything, is you're running a separate web server. By extracting the knowledge that you use to build the plot and then doing the value changing in JavaScript, is now we can have static websites that are just HTML files being served. and we're going to see an example of this, I believe, later. Steve's going to show us one, that you can actually change your values in real time and have them update. So we can see here. So this is just a small web app that I've got that I'm working in my lab. Again, it's quite small because of the size of the screen, but you can see that you can start embedding this stuff statically. So, I mean, this is like the real gains we're getting here is like, I don't know how to emphasize this enough, but by just working that slightly differently is we can now start exporting graphs outside of notebooks and then putting them pretty much anywhere that, well, anywhere that a web browser accepts. It also means that the graphs are reproducible. So like before I told you, I'm going to send my notebook to Steve and then Steve has to re-execute everything. Is because everything here is self-contained, it's all inside that one file and there's nothing to re-execute, nothing that's going to be modified, everything's going to be reproducible. Also, some of the gains that we can do from doing Python plus custom JavaScript is with some little extras. So like up until now, I've seen bokeh, so I have got a few Plotly examples working, as you can see here, is we can add things that we couldn't do in pure Python. So to begin with is all of the interactivity nowadays is mostly done, well, not all, so mostly done through JavaScript. But there's still like certain things, like I don't know if there's a Python library that allow me to click on a point, for example. This is just a wrap, so like I clicked on the point 6, it brought up an alert box, and I also copied that point to my clipboard. So like here you can see that I've just clicked copy, paste, and it's got 6, and if I click on a different point, so I've got 7 up now, and if I click paste down here, I can then paste 7. So like this custom interactivity that there might not necessarily be a Python wrapper that actually allows you to do it. So it gives not only the portability of doing stuff with JavaScript, but it gives you that extra extensible stuff, interactive things that you can think of. I mean, I'm not too sure all of the possibilities out there, but I'm pretty sure you can't click to copy straight to copy that. Can't copy straight to clipboard from clicking on graphs in most Python libraries. So how do we get to this sort of like, is it a lot of work to get here? Like what needs to be done? So like I said a minute ago is, I'm not sure what percentage, but most of the well-known ones, so certainly Plotly and bokeh, are both based off of JavaScript libraries. I'm not sure how matplotlib gets its interactivity. I'm not sure where that comes through from. And I know there's other JavaScript libraries that are imported to Python with wrappers. So as far as I'm aware, is like probably 90% of all Python libraries that are going to give you graphing are JavaScript based. So the complex interactivity in general, so what we've seen is going to be relying on a Python to update the backend. So that means we always have to have a Python server running. And that's why these graphs aren't working outside of the Jupyter Notebook environment, because when I change my slider, it's creating a Python callback, and then that hook isn't getting, like, there's nothing to execute that hook, so it's not working. So what if we can make those happen with JavaScript? So there's the idea of just doing pure math. So we've got the input data and we can just do everything in JavaScript. And then so that's like one way of doing it. So like one way is we have our base data and then we can carry out different mathematical functions, different callbacks inside pure JavaScript. And the other way is, rather than having JavaScript compute new values, is we inject into our graph different pre-computed values. So if you just think back to that one where I showed you where we changed variables, is I'm not actually calculating anything in JavaScript there. I've just got all of my data inside that graph and I'm just flicking through the different pointers to the data. So that was most of the theory. I don't know if you got any questions or remarks. Otherwise, I think I mean, it's time to show a few examples of how this stuff actually works, what's involved, and yeah, so if there's any questions at this point, just feel free to ask.
Okay, just go ahead and unmute. Folks.
I think a quick check. Matplotlib also uses the, what is it called, D3.js?
D3.js.
It's a big library, yeah. Partly and other stuff, but it's also JavaScript. Yeah. And there are also all these out there, VisAir, or I don't know how they're called. They're all JavaScript as well, right?
Which one was that, Peter?
Out there, VisAir.
I think Altair might be.
I don't remember, but the one generally here. And I think, do you know why they are all? I mean, you said they're all JavaScript based. Do you know why?
I'm guessing, like this is like a shot in the wild. I mean, I haven't really looked. Seeing is most of the interactive data nowadays goes through like Jupyter or something like that. I mean, the JavaScript is just you need a browser, and nowadays these browsers can be built into anything. So like you've got the Chromium browsers or whatever that are built into. Like you can embed the browsers inside apps. Is it like Electron apps or whatever? You can create like apps on your desktop that are like act as a program, but they're actually just web browsers in disguise. And the same with like the Jupyter, because I'm not sure that all these libraries were available, or at least as in depth on the Python side before sort of like the Jupyter ecosystem come around. I wasn't doing scientific computing then.
I think Jupyter is pushing things towards having JavaScript backends in them. Because if you just look at some of the backends for some of the libraries that you can choose between, like Matplotlib, you choose between inline, notebook. You can also choose a Qt, and get you can get a different separate window out. So then there was these different sort of backend you have to choose of where to render, and the fact that your notebook is just a web app, so everything's JavaScript. You're working in a JavaScript client, talking to a server. That's, I think, why all the libraries are sort of implementing things in there.
I guess before it was Flash, right? And now it's JavaScript.
Martin's got his hand up.
Yeah, I was just wondering in terms of how much, or if you found any issues so far trying to share the actual data, because presumably you'll need to give whatever data file you're using to generate the plot as well. Or
so the beauty of this is when you create the data, when you create a plot with Jupyter or whatever, is the data is embedded inside the plot. So all the plots that you create are standalone files. So when we're actually creating, we're going to see the examples a bit later, but when you actually create the HTML from the Python code, is the data is embedded inside that HTML, which means that they don't need the data files or anything to begin with. I can, like, if I can create something, I'll create something later, and I can just send that straight to Steve, and everything's contained in that one file. So it's like where I was talking about the portability, is we don't need, they don't need access to the data. Sorry?
Presumably you potentially end up with quite big HTML files that you then need to throw around.
Yes, that is the, that does occur.
Yeah, but I think Kurt had a question. He said, are there any situations you could recommend not taking the JavaScript approach? And then I can think of two. Was one that because you have to embed all this data, you're almost like embedding all the combinations of data you're going to need to keep the plot alive. That can get big. So if you have a big search space, that's going to take a long time to generate and have a big file. And then the second case is sometimes you might find yourself trying to replicate stuff that you would easily do in Python and JavaScript in terms of some of the pure maths, and that might not be worth it or attractive. But
so there's also the difference if we just go back quickly to like the slide just here. So like when I was saying there's like the pure maths. So if you've got like pure mathematical functions, you don't have to embed the millions of files. So that's kind of like that side. And then when you're talking about like using Python to carry out the compute, is then like you say, is there's maybe times of doing stuff in Python's a lot easier because the scientific ecosystem around doing things is a lot more substantial. It's a lot more mature. But you can inject the pre-computed values into pure JavaScript. So the reason, like I think what Steve said was important, is the reason I wouldn't use it is if you got like continuous values and you wanted to have all of them working, that wouldn't work in JavaScript. So like just a quick example. So I work in climate sciences. Like if I wanted to calculate, like if I wanted just two sliders, for example, where it allows you to choose the mean and it allows you to choose the longitude and latitude. but they're continuous variables from minus 180 to 180 and minus 90 to 90. Is that's going to like, that's a big search space, whereas and like if I did that all in pure JavaScript, because I'd end up doing lots and lots and lots of layers of itself, and that gets you can't do like continuous variables like that too well in this manner unless you're doing pure maths inside the JavaScript. I'm not sure if I'm clear there at all.
I think you should jump to some examples, Wesley. I think if you show a few examples with some of the code, I think it's going to be much easier for, everybody will see what we're talking about.
Yeah, so this is all the stuff we aimed at getting done. I'm not sure how much actually ended up in the final presentation now. So we're going to start off by looking at some of those pure JavaScript examples. We've just got a simple example, or a simple and a simple plus example, and then an array-based one. And then we're going to look at some of the libraries that allow us to pre-compute the data inside Python and then push it inside the JavaScript. So yeah. So pure JavaScript is the easiest way I found. I mean, people may jump in here and say there's better ways of doing this, but I found that Bokeh's got built-in functionality. It seems to work really well for this. So what you need to do is we need to create a column data source that holds the data. We create a plot that's based off of this source, and then we add a callback. So what does that actually look like? Is here's Dieter's example of an impulse response. So here's the graph, and what we can see is underneath here, he's got a little time slider. And when I'm varying this time slider, so here again, as we're talking about, this is this is what we're talking about earlier, is like the search space. So like if I thought like it goes from 1 to 100. So if I was actually storing the values of those 100 inside that graph, is I've suddenly got like 100 layers by, I don't know how many points there are. So the data starts getting really big. So this is what we're talking about, big search space. So here we can see we're smoothing through, and we can just compute those values on the fly really nicely. Yep, so like if we just take a look quickly how this is done now. So we start off, as I was saying before, so we're using the bokeh. So we start off by importing the column data source. We create the source with some data. So here is Dieter is filling in the time and the e-field data. I'm sorry, I'm not a geophysicist. I'm not too sure what all the rest of the stuff is, but we can see it was calculated just up here. So this is the log space where you had 300 values. So if we just quickly go back to before, is you'd have 300 values and then you had 100 layers. That's like 300 times 100 points of data to store inside the graph. So we've got the source of the data, and then we're going to create that custom JavaScript. So this is the JavaScript part that we're adding inside of the Python code. So we can see that like all around this is all just Python code. And then here, writing this custom JS is we give it a source. So we're saying the source of this data is this column data source, and we write the code. So we can see here, the first thing he does is he pulls out the data from the source. So the data is going to be these values up here. So data is set here. So you're going to have time and e-field. And the CV obj is the built-in bokeh object. It's called the callback object. So when we assign this callback to something, it's going to be the object itself. So in Dieter's case before, he had a little time slider. So in cvobj.value, that's going to be giving him back, I'm not sure what res means. Again, sorry, I'm not a geophysicist, but that's going to be giving back the value that he wants to use. All the rest.
The slider is resistivity. You got time versus amplitude, but you change the resistivity of the subsurface. Well, yeah.
Yeah, thank you. Yeah, sorry about that. You're probably going, oh God, what's he talking about? So you can see all the rest of the stuff he's setting up here. Is he's just setting up the rest of the variables that he's going to use. And what happens is this main big bit of chunk of data here. So this is just a for loop written in JavaScript, where he's calculating the different values, and then he's updating the e-field I. So if we go back to the top here, we can see that he was doing time and the e-field. You're probably going to tell me e-field isn't, it's like probably something I shouldn't be calling it e-field in, like it's going to be
the electric field.
Electric field, thank you. So he's calculating the electric field at each point by multiplying the different factors that he's calculated above here. So we can see that there's certain math functions that are feasible. So we've got power functions, we've got square root functions, and exponential functions here. But yes, he does all his calculations, And then when he's reset his electricity field, when he's reset all the values, he's going to say, okay, my data has now changed. And that's going to say the bokeh is going to pick up that that callback and go, okay, data's changed, replot my plot. So now we need to attach this callback to something. So we can see here, we just call this callback. It's just like, it's not attached to anything. So we're going to attach this to a slider. So we can see here, slider JavaScript on change. So when the slider changes its value, we're going to trigger this callback. And finally, the last bit is just to create a figure. And then with that figure is we pass it. We're going to plot a line. So this is how you make a line in bokeh. And we're going to feed it that source, which is the important part. It's like we're not feeding it data, we're feeding it this column source data here. So this ensures that when the column source data changes, because we've moved the slider, is the plot is updated. And that's pretty much it. Sorry, that's it. So that's the JavaScript update that's going to allow us to have that slider work in pure JavaScript and now become portable. So in this case here is we just had a simple slider, and then I believe Steve might want to talk about this one where he added multiple sliders at the top here, so we can see that we got Sigma. Sorry about I haven't tried this on my laptop. It's a bit of a shame about the sizing issues. That's not going to work either. Trying to be too clever doing this. So we can see here we now got two sliders. So when I move, you can see it just about moving. There we go. So when I move mu, we're getting the offset while the mu bit moving, and we can move sigma moves the amplitude.
I could show a couple of things on this in the notebook. Wesley,
yeah,
this would be a good time to do that.
Cool.
So
stop sharing.
I know, Dieter, when you put that example together, you hit a couple of different questions, and if anybody can see my screen, okay.
Yep.
Then you hit a couple of questions, and a couple of those questions were, well, what if I want to get multiple sliders involved? And the other one was, what if I want to do something more sophisticated than just this maths library? So let's take a quick look at those two things. So first one is this plot that Wesley was just showing. And I was going to do some, I'm going to make some wavelet versions of this one so we can play with like almost be wavelet and that type of thing. But in order to hook these two sliders up, I basically had to just fool the column data source. So the thing about the column data source is it wants to hold tabular data, and it insists that all its variables are the same length. So in order to trick it, to get around that, what you can do is just pack your variables in another layer of nesting. So if you put everything into an extra list, so you have lists on lists, and you change to a multi-line plot, then when it comes down in your JavaScript, you do the same thing. You pick up the source data, and then what I do is when I do my plot, you'll just see there's an extra level of dereferencing on everything. So to get my constant sigma out, it's sigma 0. And to get my array of x out, it's just x of 0 and then I. So it's very simple change to add that next level of nesting. And then the second trick is, the way bokeh works is this callback will get fired. The same callback will get fired from both sliders in this case. And I guess you could go and make different separate callbacks if you want. But if you've got them both hooked up to one callback, then the callback gets the title of the slider that was called in the callback object. And then if you just make sure that the name and the data source, the slider title lines up, then it's very easy just to actually update your column data source based on the right slider being moved. And then you can follow that pattern, and you can put multiple controls on the same plot easily. So that's a way to get multiple controls in there. And I'll share these examples anyway, but that's one way. The second thing is, of course, this math library is pretty limited in JavaScript. Well, it's got some quirks as well. For example, it doesn't like, it can't do negative, like power can't do negative fractional powers, or it can't do fractional powers on a negative base. It will throw a nan for that. So you might want to get something with a bit better math support involved. And this is where we sort of lean back on IPython a bit. Because if we remember that everything's JavaScript here in Jupyter, then we can inject JavaScript on page by just using the IPython functions. So for example, if I execute that cell, it's going to add a script tag to the page with the function shout, and it's going to call it, so we get an alert. And then that function is available in the whole page, not just the cell. So that means we can come along and do this, for example. And here, what I'm doing is I'm using the IPython core display JavaScript object, and I'm telling it, I don't have any JavaScript data, but please load the library, the maths.js library from the CDN for me.
Steve,
and then at that point, sorry, yeah.
I'll just jump in. Can you just make your screen size a bit bigger? If you just like increase the font size of the, we can maybe see a bit easier.
Cool.
Cool, thanks.
Yeah. So then we can just inject any library we want, and that's maths.js in this case, but it could also be num.js to get like a NumPy type clone, or whatever you need from JavaScript world. And then you can come in and start doing some more sophisticated maths. And there's the error function data that you couldn't find on the basic maths library. So now you can bring in some more sophisticated stuff. And that's exactly what I did back here.
That is cool. Yeah.
Where all I've done is the top of the cell, inject the maths library, and then I can use it straight away in the bokeh callback. So I'm just computing the error function with a factor on the X variable there. And that works nicely. So just to go back to some of the discussion that we've been saying, we've been talking about two things. We've been talking about a way of using JavaScript to, well, using this JavaScript callback so far to nicely hook up our plots to some data in a way that stays pretty compact. And this means you can recompute on the fly variations of your function. So that means your HTML file stays much smaller, but you've now got to start moving some of your analysis or some of your stuff out of Python into JavaScript, which is an extra pain there. For example, here I have to compute the initial state in my graph here in Python and then the change state in JavaScript. So there's a bit of extra work there, but the size of the plot and the size of the HTML file won't increase massively during that method, using that method. When you want to go the other way, and you want to try and do everything in Python and do an embed with panel, which I think Wesley's going to show next, that's when you start generating larger data structures that get stored inside the HTML file. But this is a nice little middle ground if you just want to sprinkle a little bit in, especially if you're doing stuff like this, where you're not exploring data and you might maybe building teaching or example material out. I can see us, getting a lot of the way there, especially since there's FFT libraries easily available. And there's a few little bits and pieces available that wouldn't be too expensive to compute on this style of data and would be pretty effective as interactive examples. Cool. I'll stop there and hand back to Wesley, but if there's any questions on that stuff, please shout.
Cool. Thanks, Steve.
Cool.
So this is just a quick one before giving it back to you, I think, just showing you rather than having the compute values in the JavaScript, is we're just going to be pre-computing the values before. and then injecting them straight into the JavaScript. So here I've got a plot, which is the paleo current topography. Not quite sure that looks like current topography. It might not be too long ago. Of the world, and I've got one variable I'm showing. I can see that I can go interact with my plot, like we're saying earlier. I can get zoom, do what I want. And then I've got this little slider, a little widget at the top here. I can just go and switch over. So this is different basins, and this is just another variable inside that same file. And these are all values I've actually pre-computed, and I'm just injecting into my JavaScript. If we just take a quick look at how this is done, is what I do is we use netcdf files, which are climate. I mean, there's like I'm not quite sure, so it's like labeled data arrays. So we use the X-array library, and just to get all the data out. So here is I just cycle through my data variables, and I've created a dictionary. I probably should have highlighted that as well. So I create a dictionary with each dictionary, with each data variable. So this is the name here. I'm just injecting into the dictionary with the key is the variable name, and the value is the values. It's just all the values at different coordinates. The next little trick is that the bokeh plot will only plot one thing at a time. So we're plotting one variable. So I just create a dummy variable, which is called to plot. And I'm just giving that the values of my first object, my first data object in my array. And then as before, as we're creating that column data source, and then we create a callback. So in this callback is we're just updating the data to plot is because, like we said earlier, we had the callback object, is we can just get the callback object's values. This is kind of like what Steve was doing with his title. So we're just getting the hold of the value, like the name of the object, and we're just changing the data to plot to the new data because the data is what was passed through as the source. And then we commit that change, and that's how we're going to be up. We can inject pre-computed data inside a bokeh plot really quickly and get the values. So that was, well, it's probably written the wrong thing there. So that was embedding pre-computed data manually, I guess, like through the JavaScript. And then we can actually do this as well with different libraries that are available, notably the Holoviews libraries. So like we're talking about earlier with Holoviews and with Panel. When we're coming up to this is panel.save is not working. It complains about, what was it complaining about? It was complaining about having a callback function that was written in Python and not in pure JavaScript. Whereas if you do panel.embed, that embeds it inside the notebook file perfectly using the correct JavaScript calls by pre-computing the data. So you can actually, in this embed function, you can say how many different states you want it to do. So if you've got a continuous variable or continuous slider, is that it gives you a set number, like a predefined number of snapshots, I guess, to your data. That's how the embed works. So the reason I'm not doing this one live here, and we're using CurveNote, is because it can upload to CurveNote fine. So here's a little example. So there is the example of using the other one. And here, so here we can see the code. So what I'm using is I'm using Interact by Panel, which is, I think it's in their later releases. It's really cool. It just allows you to create interactive data really quickly. And hvplot.xarrays, this is the X-array based stuff. But I mean, it'll work with NumPy or anything. I mean, so here what we do is we load the data set. So this is just a big data file. There you go, it's just a data file on my machine. We create a function. So this is my plotting function. So here we can see it's a Python. This is a pure Python function. And what it's going to be returning is when I change the variable here, it's going to plot as an image format. So it's just like the 2D image format here, and using the Viridis color map. And then I'm just going to be calling interact. Here, I give it the plot. And then here, this guy's expecting a variable. So I just feed it the possible variable values, which is my data variables. In this case here, I've only got one. And we call this embed function. So like the embed I was saying earlier is here is if you've got multiple possible states, if you can tell it the maximum number of states. And here I've got my plot that's working. Plot's kind of unfortunate, so I'm just going to open this up maybe inside CurveNote. Let's see if I'm just logged in to CurveNote quickly. Right, switch browsers. Here we go. So here we've got the same example I was talking about before. So you can see how I've got multiple values. It was just getting cut off. And here I've got different coordinate systems. So this is the bit, this bit here on the side here is what's automatically added by Holoviews and Panel. So I mean, I'd really recommend trying to get hold of using this library. It's really cool. And it's all it's bokeh based, but you can do it in Plotly and Matplotlib as well. And as I scroll through my different values here, I can see my plots automatically updating with the pre-computed values. And similarly here I've got a time counter with those pre-computed values that are built in. I've also got a different examples. Yeah.
Because I've been playing with this and it does do some magic, doesn't it? Because at no point in your code snippet there are you declaring. I mean, I can see why it's using bokeh, and that's because you've called HK plot image there.
It uses bokeh because when you import by default, the way to write this is you write HV or holoviews.extension and you give it the extension name. Yeah. But because you call import hvplot.xarray, it does that for you. So it automatically loads bokeh in there. So bokeh is getting called as the Holoviews backend here.
Got you. And I can see that in a plot. And then in plot, you're calling HV plot, and it just knows how to use bokeh.
It knows how to use the image because in netcdf files, I haven't got it in this one. So if I just go back to here and go to this guy, hopefully I show some data in here. If it loads in. So this is some of the bigger files now we're talking about. When someone asked the question earlier, what's a big file is here. Oh, it just crashed my tab, didn't it? These guys are hitting like 40, 50 megabytes, I think. And if it doesn't work, I can maybe, no, that's a 404. And that's got something working. Oh, here you go. Here we've got something working. So it's actually got the coordinate systems in here. They're written implicitly inside the netcdf files. So that's how it knows to use the longitudes and latitudes when I call image by default. It's because of the niceties between Xarray and Holoviews.
And the same thing, it looks inside the netcdf file, sees something that looks like a list, and then decides you want a drop down automatically. Is that how you get your drop down?
Where was I?
I think you were back in the other browser.
I think update static .NET. Is this one? Okay. So how that works is that's part of the interact cleverness. So you can either feed it a panel widget if it doesn't do what you're expecting it to do, but because I can just go back to the other one. Because here I'm feeding it a list, it recognizes a list being a multiple select. Similarly, as we saw before, I had like a time counter variable, which has 12 values. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, just like time steps. And it's considered that as rather than being a time slider as objects, so that's why that one was a drop down, whereas the vegetation was actually a time slider, which is just some quirks, I guess, of the panel. But you can specify what you want. Like here, we can see that it decided vegetation classes, even though there was 12 as before. Is a time slider, or is it decided time counter with a drop down? But that it all handles under the hood, and you can specify that manually if you need to.
I guess you just got to learn the magic and then how to override it.
Yeah. I think I've probably got some examples, or I can show some examples later if that's needed. Cool. So this was panel embed, and then it's back to you, Steve. I think that's pretty much most of my examples on this end that I wanted to show. So.
Yeah, I think I've done half of this demo already, but let's go back. There's a couple more things to look at. So the thing there, your map data, basically everything in your netcdf file ended up being embedded inside the panel. So you had 12 different time steps or 12 different versions of that map data. That's all going to be pulled in and put inside the HTML.
Yes, but when you create I can manipulate my netcdf file to select out, like query out stuff I want. Like you do with pandas, like, I don't know, if you don't want all your columns, you just query your columns that you want. But
Yeah,
all
yeah.
that data has been embedded. Yes.
Yeah, it doesn't have to be exactly. It doesn't have to be the whole thing, but yeah, the data, all of the data you want to show gets pulled in. Cool. So I showed that one. I just wanted to show. Well, there's another couple of examples to go through before maybe we get some people to talk about their experiences and stuff. But just to look at that notebook, sorry, interact example again from panel. So here, this is one of the, here we've loaded the panel stuff up. We've loaded the panel interact. We're in Jupyter Lab. We have to make this extension call in order for it to get it to work. And then we've defined this function that's computing the sine wave for us. And the interesting thing between these two is we run this in the notebook and it works. Oh, or it doesn't. Wait a second. This is the point. If we run this in the notebook, so if I actually run these cells and get that to replot, there we go. Panel with that one there. Then this all works fine. It's actively connected to the kernel. It's calling the sine function here to do its stuff. If I save that and just refresh the page, and then come back down to that, that gets us, oh, that's my JavaScript shouting. That gets us into what I think is a common trap where it looks like, oh, here we are again, and it's not working. And that's because the kernel's been restarted. This function is no longer hooked up to anything, and we're just seeing the last plot. But if we go to this one where all we've done is call the embed function on the end, then this one survived the refresh. We haven't had to do the kernel. So this keeps your notebook alive. And then this version is where that's going to work if you go and open that in KervNote, or if you go and embed that in a reveal.js thing, or you go and embed that in an iframe anywhere, or get it out to XML. Sorry, HTML. So the important thing is just that one call changes everything. And it's nice because you're still writing your Python code. I started doing the same with, I'm going to make a sort of, it'd be nice to have a sort of Bruges demo where we can actually go and check off and go through the different libraries, the wavelets available in Bruges, for example, and play with their parameters. And again, that works exactly the same. It's pretty quick and easy to put there's the call to Bruges, pretty quick and easy to put the calls together. And as long as we don't go crazy with the sliders and the size of the search space, then things will stay pretty compact. I think that's it there. I'll say sort of on bokeh. Another couple of points is IPy widgets. I know people use IPy widgets quite a bit, and they're the sort of first go-to. But they have this problem again where I think there's, this has got a kernel running, so it works because it's been able again to hook up the slider to the callback and go and pick out a different image. But now if I go and just stop the kernel, of course, then that stops working. And this is an issue in a way that a lot of the time you want to go off and try and embed these things. And if you are using the sort of Jupyter Book Classic interface, it gives you this way of doing that, where if I just run these, quickly we get this back to working. you can come in here and say embed widgets, and that gives you what looks like exactly the HTML you need to go and make a standalone widget. You can copy that to clipboard, put it in a file, but you will be back in the same problem that you get when you disconnect from the kernel, because you won't be able to you won't actually be able to change that data. Cool. And I guess we're still exploring. There's some really good examples out there. What I tried to do ahead of the call was to start looking at some of the better 3D ones. There is a library called K3D, which does some lovely 3D rendering of data sets. And I started looking at this one because it has a sort of embed function called snapshot. Just a second. It has an embed function called snapshot that is supposed to do exactly this and give you an HTML page out, but unfortunately, it doesn't work. Well, I haven't managed to get it to work on any of the examples so far. But that might be a good one to explore and see what it takes to get working. It should work, because if we go up to the Jupyter.org widgets page, they have somehow managed to embed a K3D in here, but their snapshot function that's supposed to sort of give you this package in an HTML snippet isn't working in the current version anyway. But there's some potential there. And maybe, I don't know, I haven't used much PyVista. Maybe somebody else has. Maybe PyVista is already ahead and is allowing you to sort of embed some of these views already without having a kernel connected. Cool. So that's all I had to show, really.
I was just going to show one last thing, I guess, because like up until now we've showed how to get JavaScript running in the notebook still, and it was just that, like, the last little step, going from either saving that to a HTML file or getting the components out of that object. So just like quickly showing, so like you've seen with CurveNote, you can just click send it to CurveNote straight from Jupyter, but maybe like how we actually, or how I was getting those plots out and just create a real simple presentation with these interactive plots. So I'll share my screen again and we can go through that quickly. And take it this time, we're going to use just a basic, it's not connecting to that guy. I got another one running. Cool. So here I've just got some notebooks running. I'll just create a new one. So in this one, I'm just going to import NumPy. I'm going to import panel. I'm maybe just going to import Holoviews as well. I'm not quite too sure what I'm going to use. That should do. So let's just create some data. So data is equal to numpy.random.randn. We'll just create something like 25.reshape -5, 5. So now we've got some data, which you can see just underneath here. Just print that out. So we've got some data in there. So now comes the plotting part. So I can do hv.image. So I'm going to use Holoviews here. We probably do a similar thing with panel. I can maybe show that in a minute. So you do hv.image data. And why isn't that? I don't think I've got this is just a Docker container. Sorry, no, I just need to connect to my server. Yeah. Cool. So let's try it. Do this again. I'll just copy this. Well, it's going to log me in. Here we go. Let's create a notebook. Right, here we go. So if we go back to there, that should work now. And then if I go back into this guy and just grab my data again. Data. So here we go. So we're back at the state where we were before. So now I'm going to do my image. And I'm going to cool. This is what I was saying about earlier. So it may have well have worked before. So you got to do the HV extension bokeh. And I'm just so used to doing the HV plot X-ray. So here we go. So now I've got my plot in here. I can add the Holo tool to it, just with that, like this. Tools. So now I've got my hover, just to get a little hover. So now it's like, how do we go from getting this image here into something useful like I was doing to show my presentations? So what we're going to do is in bokeh. So this is bokeh based. So like all the stuff we've talked about today is bokeh based. I've got a quick Plotly example later, but the way we've been going so far is with bokeh. So you import bokeh.embed from bokeh.embed, import components. So if you type like bokeh embed, there's a couple of ways it can tell you how to do this, but I found this has been the most fail-safe way. So we're just going to call this guy here plot, and I'm just going to view plot. So we've got the plot back here again. And now is if I call components on plot, it's going to throw me an error because components, because it's bokeh, it's expecting a bokeh object. So this took me a while to actually read through the Holoviews doc. But what you do is if I type here type of plot, it's a Holoviews image. And if I type get root on that, it gets not get root. Is that any panel then? Let's try doing this with panel quickly then. So if I just call a plot function, that's it. Yeah, I can just do here. I can just do pn.panel. So I've just created a pane object around there, which is a pain in the ass. Sorry, bad joke. So now if I do type plot, it's now a panel object, panel plot, and now on that guy I can call get root, and now it's giving me back a bokeh model. And this guy here is complaining it's like it's either got to be a bokeh model document or something. So the little trick is creating that panel object around your Holoviews image, or creating a panel sort of like mini dashboard app thing that does something. And then you can get root on that to get you the bokeh model, get root. And this guy here is going to give me back a script and the div that's corresponding to that. So I can just call that. And then if I actually do here, if I do print div, as you can see, it's giving me the HTML div object. And if I do print script, it's giving me the HTML script object. And as we were talking about earlier, is the data is embedded in here. I'm trying to see where it's embedded. It generally gives you like a big long line of values. I'm guessing it's probably this guy here. That looks like it to me. Looks like it actually be the data object. There you go, image ND array, data object. So this is when you see the data is embedded. So like if you've got multiple values of this pre-computed stuff, it just gets really big in there. But anyway, so we've now got the script and the div. So if you head to my, I can put this stuff in later, but if you head to my GitHub, I don't know if I'm logged in on this machine. It's open anyway. So if you head to my GitHub, there we go. Let's see all my stuff. Is in here, I should have a repository called reveal.js one-line file, single file. There you go, reveal.js single file. And you can just download this index file. So if I just click download, save page as index.html. Just gonna go to my downloads, cool. So I open that, is it gonna open it straight away? Yes, it's gonna open it straight away. Let's just upload that to Jupyter Lab just while we're doing everything in Jupyter. Upload, download, index. So I can now edit this, open with editor. Here we go. Yeah, so Steve told me earlier that it was hideous that I did my whole presentation using pure HTML like this, but it works kind of nicely for what I need to do. And I need to go there. So if I go back here now, is I can just copy this script. So I just copy all that. So Control C, and come over here. Here I'm just going to create. I'm just going to create a new section. Paste that script in, and then if I come back to this guy, and now I print the div, and just copy and paste that up. This guy again. Stay on page, and there's too many things flashing everywhere. The div, and then I need to close the section that I just created. So that should work. And now if I open this, I'm not too sure how well this is going to work in here. Yeah, it's not working at all in there. So I'm just going to download that file again, just to save it off of my machine. Cool. And now if I open up that file, I should have my reveal.js. This is slide 1, slide 2. And then I've got my extra one, which I've added in, which doesn't appear to be working. But that's how you get it to work. This is probably because it doesn't like being inside. Safari seems to be a no-no as well, like on our things. Safari doesn't seem to play ball, but that's how you get it in there. I'm not quite too sure why it's not working. But it's that manipulation of just doing the get components here, the components and the div, and then copying and pasting the script and the div inside the reveal.js file, and that should get it all working. Oh, I know why it's not working. It's because it doesn't have bokeh loading in. So in this reveal.js file, I can just go and edit it quickly so I can show you the whole thing working. So if I go here to downloads and I open up this with Visual Studio Code, here we go. So we can see it all now. Is what's happening is in here, this is the script I just pasted in. Here we can see it's the type, sorry, if I just format the document. This is the bokeh script here. And to get this bokeh script to actually work inside the real.js is we need to give it the headers. So I'm just going to go over to my presentation, which happens to be here, and just go and grab those headers. Is it below the CSS? No, it's above the CSS. So here they are here. So you can check these out on the website. It's just a couple of scripts to load. And if I go and chuck this in the head file on my HTML, is now, if I go back to that guy, we can see it's working down here. And I just need to disable that stupid auto. Right, here we go. So now we've got the slide, and now we can see here, it's just injected that plot that's working inside it in a graphical manner with the zoom, the pan. And this is exactly how I got, oh, sorry, I switched the pan off. This is exactly how I got all my plots from Jupyter inside my presentation today. So if you want to do a presentation that works in this interactive manner, where you want to talk about things, you can use that. Another quick example of what you can do with this, so now I've got this index file, is what you can do is if you go to a GitHub repository, which is nice and easy. I've go to a signed in one. So here I'm signed in. So if I go to GitHub, if I go to my repositories, so this is the presentation for today. So like I said, is I stick this stuff in the Swung channel. Well, I don't know what's happening there. I stick this stuff in the Swung channel, but I've just uploaded the index.html file. So that was the file, my reveal.js presentation file. And then if you go into settings here, and you go down to the GitHub pages, and you set the source being your main branch or the branch that you want to deploy this off of, and just set up where you want it, like where you want it to look, is what I can now do is if I go to this site here, and if anyone goes to this site, it's not quite finished, this presentation. I mean, I haven't got the latest version, but we've just now deployed this static HTML file online, and all of that interactivity I was talking to you about earlier. So is all work. Well, it doesn't work in Safari, but if you use a normal browser, all of the interactivity I was talking to you about earlier is now working and being rendered online in an accessible manner for anyone to use. So like I can just chuck this in the chat here.
Cool.
If I can find the chat again.
I've already pasted it in Swan. So.
There you go. Awesome.
Yeah,
cool. So that's an easy way to sort of like, distribute these graphs. And that's kind of like the last step. And also if you go from Jupyter, I think there's like a save button. Maybe you can tell Steve is like, you can save the output file a bit quicker from bokeh or panel. But that's like the kind of like the step I think that maybe missing that we didn't talk too much about is how to go from these extra JavaScript based plots inside Jupyter and how we actually share those. So hopefully that just covers off that last little bit. Cool. Yeah, I've got the plot example as well. I
think if anybody has any questions, and there's a few things in the chat as well. Dita, you all wanted to talk about, did you want to mention this link that you posted?
Yes, I'm already half shutting down. Yeah, that's just this, what did you show, the K3D? Or what was it called, Steve?
Yes, K3D it was called.
This link I shared, that was panel and PyVista, that you have these embedded plots, you can zoom in and move it around. According to Bain, right now with panel it's broken, but PyVista and VTK, they bring out soon something that replaces that, so it should be possible, because you also ask about PyVista.
Cool.
Of course, there's no slide or nothing, it's just a figure, but I do think PyVista has something in the pipelines for more interactivity as well.
Okay, so this will be meshes, surfaces, anything. Do you know if they can they do texture stuff, or I guess this is?
There are examples with you would have to actually check the PyVista docs. I do think he has interactive examples here.
Cool.
This example is funny because it used to work 2 years ago. If you do it with updated panel and PyVista, it won't work. So you will have to use old versions to make it work.
Right. That's very cool. That links in the chat.
There's actually an example that started in Transform 19, 2 years ago.
Cool. And I think, Matteo, you were mentioning Napari. I haven't looked at that. Have you actually looked at that? Is that something you want to speak to? What tell us about?
I have not used it, but it's actively being developed by some of the folks that also contribute to Scikit image. So I will just browse to the image gallery and looked at some of the tutorials they're putting together. So I'm just saying that's, something to try. I have not myself yet.
Okay. Cool. It looks like an app rather than being browser-based, do you think? Or... Yeah, sure. Okay, cool. I'll post that. Make sure that gets posted back to the chat too. I think Doug had a question early on about Voila as well, and I guess that takes us over to sort of full server-side rendering and running of the server in order to produce an app dashboard, a bit like what you're going to get for the panel, but that is, remains connected to your data and connected to a kernel, etc. I've started up some of the examples, and as long as, the app seems to work very well, as long as you can have that server up and running somewhere, I guess.
Yeah, I guess for me, like, so coming from the newbie end of the spectrum, it's knowing where to start, right? And like that conversation, let's say Voila versus panel, it's not necessarily obvious to know what's the right thing to do, if that makes sense.
Yeah, I think the distinction is if you if you want to host an app and if you want to host a server and have that running, and you might want to do that because the interactivity isn't any use unless you can reach into the whole data set. Like if you've got a cube or something that you need to, then maybe server side makes more sense there. Or if you need to fetch new data. But if you're looking for an example that, like some of the ones we've seen today, which just you want it to be standalone, that if you post it somewhere or share that file with somebody, that it still works in itself, or if you just want to host it up on GitHub Pages or somewhere without a server, then that's the sort of line we're exploring today, which is the sort of the panel side of things. What's interesting is Michael Harty from Oxy has been playing with Streamlit.
Yeah.
And I think he's going to do one of these next Friday. He wanted to do one on Streamlit. And I think he's teamed up with somebody to have the Dash side of things as well. To have like a side-by-side Streamlit versus Dash. Streamlit versus Dash. So that might be interesting to see that side of the...
If I make one more comment is that with Voila, you're not restricted to Python kernels. It will take Julia and other types of kernels. So that's one distinction that the developers of Voila try to make quite clear. Whereas with Panel, you're only working with Python.
Yeah, cool. And then Streamlit as well. Streamlit's only Python. But I guess with Voila, it's anything that the notebook will handle. So I could even go and code Node.js if I wanted to, or Rust, or whatever I can get a kernel for.
Yes, exactly.
Okay.
C++, that's what they're saying.
Mm.
If you like that kind of stuff.
Yeah, I think you want to be in a proper IDE when you're into that stuff. Yeah. With plenty of IntelliSense rather than being in a notebook. Cool. Was there anything else? Any other questions or comments before we wind things up?
Just if Wesley wanted to show some of his Plotly stuff he hadn't showed yet, I guess might be quite interesting. Just kind of that Plotly versus bokeh again, like coming from a newbie side, like what's the pluses and minuses of one versus the other, I guess.
Yeah, I could show that quickly. I only got one working. So I did used to use Plotly quite extensively, and I know like when you're writing Plotly, it definitely feels more JavaScript based. Is like when you're creating traces and things like that, it's like you feel like you're writing the JavaScript that goes with it. But ironically, there isn't a custom JavaScript option that I saw on there. So like I searched around the internet a bit and found what they were saying. So this is maybe a more generic way of hacking interactivity, I guess. So the idea here is we're going to create the data. Oh yeah, a disclaimer again is I'm not a pro. Dash probably needs to come into this somewhere along the line, but again, we've got Dash with the server and everything. And there's bound to be more people more appropriate to talk about this than me somewhere. So dig into it, but it's just an example I got it's working. So we're going to create the traces of the data. We're going to plot that data using the output type as div. So rather than plotting that inside the notebook, is that return the div container again. And inside that div container is we've got the div in the script. So a slight difference to what we have with the components of bokeh, whereas it was two objects, is here it's just a div containing both of them. And then we're going to link some custom JavaScript to it. So this is how I had the thing working earlier, if you remember in the presentation where I clicked on something and then I copied that to my noteboard. So what that looks like in the code is I create my traces and my data as I would usually. And like I said, is we create that plot. So here is I've just imported plot from offline, plot.offline, import plot with an output type as div. So like I said earlier, so this is going to create a div object. We then go and collect the div ID, which is some magic in there. It's just passing string. You could probably use Beautiful Soup or something like that to find it better, but anyway. And then we write our custom JavaScript. So my JavaScript here is it's just a script. I'm going to grab my Plotly object. So this is where I got the div ID for my Plotly object up here. And then because Plotly relies on JavaScript is knowing a bit the API, is when you click on the screen, is that triggers the plotly click function. And then that's going to give me the event data. And in this case here, I'm just logging the event data. But in the other examples, is I was actually copying it to my clipboard. But you can just do some custom JavaScript with that there. And then I'm just injecting that guy. I'm injecting my div ID into here. So just create a string. And then we just wrap that both up. Because it's all just string objects, so we can just wrap all this up and then just stick that in a HTML file. So I don't know if you were there earlier, Doug, but this will give me, can I not zoom in this? This will give this result here. So here's my plotly plot with some data in it. And then when I click on an object, it's calling that alert. So like I did earlier, I think I did a console.log, but it's just an alert with the point. And then here I've copied that 6 into my clipboard object. So here we've got 5. So this is what it's like. We got a plotly plot here, which is my div in my script, and then it's doing some extra stuff. I didn't have a chance to look into getting sliders and all that working, mainly because that needs dash, I think. I'm not too sure how that stuff works nicely. Well, I didn't have time to look into it. So feel free to explore, but I definitely felt that the bokeh ecosystem was more forwarding to using the custom JavaScript and easier to get these sort of things to work.
Has anybody used Altair much in Vega? Because no, I haven't either. But it just seems like I've not seen many examples in our domain anyway of people using it much at all. But it's incredibly powerful. I've used it in JavaScript before, Vega Lite, and you end up describing your entire plot in a declarative way. So you describe it in a JSON structure, and then Vega takes care of just rendering that for you. But I'd quite like to see it. I just noticed that if you look through all the different custom mine types that Jupyter supports by default, Altair is listed as one of them. So Jupyter's sort of given it a bit of a special class as it's become an official mine type. But I've yet to properly play around with it, and I haven't seen it much either. I'm guessing that nobody else has used that either. So maybe we want to look at it. Cool.
Justin's just said that he uses Altair and Vega. I just popped up in the chat.
Does it work well for that type of selection events? Because I do know that you can switch on quite easily bokeh style, box and lasso selections and start to get some interactivity back and forth.
Yeah. I'm not like done with that a lot, so I can't say really.
Okay. Cool, that's fair enough. I think maybe it's one to dig into a bit more.
I think like the real takeaway today, though, that what I wanted like everyone to sort of, if there's one thing you remember for today, is yes, there's a bunch of libraries that render stuff using servers. But if you just want a quick way to share one graph interactively with someone, you don't have to have the server running Dash or Panel or whatever you use to get there. It's like, I don't know, if you're in a consultancy and like they don't have access to the data, don't have access to the data or the server or anything that's all complicated, is through a few simple things in Jupyter, we can create a simple HTML file and send that, and everything will work inside that file. And that's like what I really wanted everyone to sort of like remember for today, is just like, yes, we can do a lot more powerful things in pure Python with all these backend servers and compute and this and that. But there's an easy way of making portable things nowadays. And there's a newer ecosystem of web-based tools that are going to allow us to distribute these in an easy manner. And that's, that's what I think is important to, what was important today.
Cool. And thank you, Wesley, for putting all that stuff together and for diving into all this stuff and getting it working. Cool. Okay. We'll see you all later. Have a great weekend.
Thanks, everyone.
Thank you very much. Have a good evening.
Bye-bye.